Hello, I'm Matt Moran. I've been developing liquid hydrogen technologies and systems for 40 years for NASA, the Department of Defense, and various commercial and industrial customers. I've also been teaching on this topic over the last several years in conferences, workshops, short courses, and webinars. And I developed a new online on-demand version of the course that takes the best edited lectures from those various other venues and condenses them into a concise and easy to learn from set of course training sessions, along with a very comprehensive set of slides that are downloadable. Let me take a few minutes and give you a preview of what this course offers. This liquid hydrogen systems course has a little over 4 hours of lectures videotaped and over 350 slides that are downloadable in PDF format. So let me show you a few of the topics that are covered in the course. In the introduction, we'll talk about liquid hydrogen history and its evolution. What are some of the new applications that are being demonstrated and operated right now with liquid hydrogen? And then a few very top-level storage options and facts about how you can store hydrogen, in what forms, and what are the benefits and disadvantages of those different forms. And then starting to look at, again, a very high level cryogenic design options in terms of keeping liquid hydrogen at the temperatures it needs to be from a thermal standpoint. And then some valuable additional reading and resources that I think you'll find very helpful as you get more into this topic. In safety, on the safety front, we're going to talk about key characteristics and drivers when it comes to safety with liquid hydrogen. What are the considerations? What are the operational scenarios that you have to be concerned about? And then what are those hazards that are associated with those safety drivers, and what mitigations are commonly used to address those hazards related to hydrogen? And then a little bit about some of the codes and standards that are available. And then finally, some training and resources on the safety front that you can turn to for more information and details. In the fundamental section, we'll talk in more depth about hydrogen properties and their states, liquid and gas primarily. And then get into the basics of the thermodynamics and thermodynamic behavior of liquid hydrogen under various conditions and scenarios. Also talk about material properties, how they change at liquid hydrogen temperatures, and they do very significantly. And then talk about heat loads, where they come from, how to take them into account, how to model and predict what your heat loads are into your liquid hydrogen storage vessel. And then finally, some insulation options, and again, benefits and disadvantages of those insulation options relative to liquid hydrogen. In the tankage area, we'll talk about different tank types of tanks, what the material options are there, and what has been used for many decades and is proven to be suitable for liquid hydrogen service. And then we'll talk about some integration examples. How do you integrate these tanks, either into a vehicle or on a ground system of some type or some other application. And all this material, by the way, is applicable to any stationary or mobile system that's going to be using or is using liquid hydrogen. And then we'll talk about tank sizing. How do you do some rough initial sizing of your tank in terms of volume and mass? And finally, talk about structural options for how to support the tanks between the inner and outer liner, in particular for vacuum jacketed tanks. In the storage section, we're going to talk about self-pressurization, which is always occurring in a tank that isn't being actively cooled. And then we'll talk about boil-off and venting, which is basically the method that the pressure rises in the tank, and then one of the mitigation strategies to keep that pressure below its maximum. And then we'll talk more importantly about how do you mitigate those venting losses or completely prevent them. And we'll get into hybrid and active cooling methods that begin to address that. As well as in the final topic in this section, we'll talk about sloshing and potential ullage collapse that can occur if you have subcooled liquid in a tank that is induced with sloshing through movement of some type. Transfer is going to be discussed in terms of chill down and flow rates that are recommended to chill down the equipment before you do a liquid hydrogen transfer. And then we'll talk a little bit about the specifics of liquid hydrogen transfer and what are the parameters that come into play there. Active pressurization, the primary method of bringing up the pressure in a supply tank before you transfer, whether you're using a pump or not. And then tank expulsions, which is essentially draining a tank or feeding an engine or fuel cell. And then some other key transfer topics. Going next to sensors, we'll talk about how you measure temperature, pressure, fill level, flow, and leak detection in liquid hydrogen systems, and start with a broad overview of what you need to think about when you're starting to design your sensors for a particular liquid hydrogen system, in particular storage tank, but also applicable to other components within your system. In the modeling section, we'll talk about what options you have for modeling and analyzing your liquid hydrogen system, and what are the trade-offs in a variety of areas, including the fidelity of your model. And then we'll talk a little bit about verification and validation, how important they are, and how you might go about doing that. Energy and mass balance, which is customarily used for first-order calculations in many cryogenic systems, including liquid hydrogen. And I'll show you how to begin to set those up and do those kinds of first order calculations. Then we'll talk a little bit about dimensionless numbers and scaling parameters that can be used if you're doing subscale testing before you do full-scale demonstration or operation of your system. And then finally talk a little bit about computational fluid dynamics modeling, which is very much used now for these types of systems. In the systems topic section, we're going to talk about the overall hydrogen architecture that can be applied to any hydrogen system, and then how you select the various parts of that architecture to actually come up with a particular hydrogen system. And our focus, of course, is going to be on liquid hydrogen, the topic of this course. We'll talk about the inputs and storage options that you have, as well as how power generation is done and other outputs when you decide to use the hydrogen later. Mission and operation considerations when you're starting to look at your overall operations of your system with your liquid hydrogen in particular, but hydrogen in general systems. And then how environments come into play in liquid hydrogen and how you have to think about that throughout the phases of your various operating scenarios. In strategy, I'll introduce you to a methodology I've developed over the years and use on all my projects that basically comes down to three large categories of steps. First planning, then development, and finally launch of the system or product. And as a case study, I'm going to use the 5,000 cubic meter liquid hydrogen Dewar tank that we designed for Kennedy Space Center and is now operational, commissioned and operational to support the Artemis program, NASA's return to the moon. And that system includes a zero boil off option capability, which uses an active cryogenic refrigeration system to maintain the tank in a zero boil off state, as well as conditioning the liquid hydrogen. So we'll use that as a case study for this section. I also include in the slides here, although it's not strictly a liquid hydrogen topic, but when you start to talk about using hydrogen in many of the other industry sectors where it's beginning to get traction, you've got to at least understand what's driving that from an economic standpoint. So I have some information here about why you would look at hydrogen for various applications. And then some of the climate data and greenhouse gas data and emissions data that have recently been published, as well as the historical information, so that you can get, if you haven't looked at this topic, get some grounding fundamentals of what's happening and what's changing and how important it is to have a portfolio of solutions to these issues where hydrogen is going to play a key role. and then what that transition to hydrogen is going to look like, and what the options and possibilities are. And then finally a wrap up, of course feedback to get your thoughts about what could be improved, as well as some information about my background, so you know what my perspective is as I'm presenting this information. And then a lot more online information, most of it freely available, that I've pulled together onto my website, so you can easily access it and use it for your systems development and design. And then finally, a little bit of a light-hearted look at some of the hydrogen myths that seem to continually come around and find their way, especially in social media, over and over again sometimes. So this last section on hydrogen myth busting, I kind of take a quick look at some of the most common ones and give you some information about that dispels basically those myths and gives you the facts. You can access the on-demand online course using the QR code on the left, taking an image of that, or going to the link shown there at the bottom for the LH2 ERA library where this course resides. Thank you for listening to this short preview and watching, and I hope you consider taking the course and helping all of us build a better future together with liquid hydrogen.